Hi, this is Chrisferb, and I'm going to review how to use a discrete probability distribution and find the expected value and the standard deviation to solve a problem. Okay, we'll get started. Okay. A part is expensive to hold in inventory and is not always in stock when requested. The distribution is shown below. This is the distribution right here. Where random variable x, these are the days right here, is the number of days between placement of the order and the receipt of the item. So what we have is the number of days listed right here, 2 to 6. So in theory, there's never any orders that come in below 2 days. And that just might be a geography thing where it won't show up in less than 2 days. And then the probability of receiving the item within the listed number of days, respectively. Okay. So then it says, based on the probability distribution, what is the average lead time and standard deviation? Okay, so the lead time, the average lead time for us is essentially it's the expected value, also known as usually the mean when we're working with statistics, but for discrete probability distributions, we call them expected value, okay? And then the standard deviation. So what we do is we use these formulas. I'm scooting up the paper. We use these formulas right here to find our answers. So the expected value answer we'll find as we're filling out this table. And then as we move on past this fourth column, then we move on and we use the expected value to find our standard deviation. Okay, so we'll get started. So I have this table listed down here below, and you can make this table with one less column. I originally have instructed in some of my classes not having this extra column right here. And it's not that we're leaving something out, we're just compressing a step. And from feedback from my students, I ended up going and adding this column in, which some people have this column, some people don't. Now I'll show you how it works. Okay, so what we do, making sure we're all on the paper in the video, what we do first is we list this all out as a table. Now, there is a way that you could, of course, do this whole calculation kind of compressed in the formula, and it would be, in my opinion, very messy, and I don't advise it. So I've always recommended doing this table method, and it's very similar to the way that you do the standard deviation using a table. Okay, so what we do first is we multiply the number of days times the probability of the part arriving, in this case, within that amount of days. So I have all these already worked out, but this one, of course, is 0.2. And then I'm just going to make sure I don't make a mistake for everybody. 1.4, 1, and 0.6. So what we're doing is just multiplying straight across. The value of the days times the probability. So that's easy. And then what we do is we sum these right here. So we sum what we just multiplied, and that will end up being our expected value. So I've already worked this out. So when we sum these right here, it ends up being 3.95. So that's 3.95. That's our expected value. So this is the answer to the average lead time part of the question. So that part's easy. And then what we do is we take this expected value and we're going to subtract it from each of the x values, which are the days. So we take, for instance, 2 days, and we subtract 3.95 from it. So, and then 3 days, subtract 3.95, and so on as we fill this this column up. So I'm going to write them in. So we end up with potentially a lot of negatives, and then of course positive numbers depending upon mean falls within our x values. Okay. So the first one is negative 1.95, and then negative 0.95, and then 0.05, and then 1.05, and then 2.05. Okay. So then what we do, this is the column that I added based on user feedback, student feedback. And that is in this column now, all that we're going to do is we're going to take these values and just square them. So before I had it where we would square them and then multiply them by a value, but it's easier just to do it this way. So we just square them. And when you're squaring a negative value in your calculator, make sure you put parentheses around it. The calculator, as smart as it is, it will make mistakes on this. So just be careful and put parentheses around your negatives. Okay. So I'm going to write these in, and that's 3.8025. And I always recommend going out to at least 4 places. I'm not a big rounding person, but I recommend go out to 4 places, and usually by then you're doing pretty good. There are times where even going out 4 places, you're not going to be close enough depending upon what you're doing. I have the answers written down so I don't make a mistake for you. And all of these notes that I'm working on right now, or the actual file that the actual piece of paper that I'm writing on right now, I'll scan into a PDF file and make available on the notes and the YouTube video. Okay, and that's what I do with all of my videos when I have handwritten notes. And some of them I made a long time ago, so I don't actually have the original papers. But moving forward, probably 6 months ago or a year ago, I started doing this. So for additional documents, make sure you take a look at the YouTube comments. Okay. So I have the values written in here. This column is now the squared values of each one of these beside it. And then the next part, the last column, is all that we're doing is we're taking these values and we're multiplying them by the probability factor, or the probability value. Make sure you don't multiply it by this column. Multiply it by this column right here. Okay. So when we multiply this value by that value, this is what we get. I'm going to write them in. Like I said, make sure you at least go out 4 places most of the time. 5.2256. Okay, so what we have is 0.3802, 0.2256, 0.0008, 0.2205, 0.4202. And then what we do is we add up our last column, and that's going to be our one of the last values that we're going to calculate before we get the root of it, and then we'll have the standard deviation. So when we add these all up, we end up with 1.2473, and then we get the root of that, 1.2473, and our square root ends up being 1.1168, and that ends up being our standard deviation. So our answer to the question, let's see, based on the probability of the based on the probability distribution, what is the average lead time and standard deviation? So therefore, our average, we could do the little dots. Therefore, our average lead time is 3.95 days, with a standard deviation of 1.1168 days, or about 1 day. If we want to, I'll scoot up. If we want to put it in terms of days, it's closer to 1 day in this case. Thank you for watching.